So our conversation this week is going to revolve around texturing. Last week we spent a lot of time talking about the model creation process for a house, and we had some really fun times working with Booleans and exploring how the snapping system was going to how we leverage the snapping system to give us the accuracy that we need. All really important points as 3D modelers. Well, today we're going to kind of change gears a little bit and start talking about the texturing side of our pipeline, because there's some things in here that are really important to begin to explore and understand. So here's my little house, okay? And we're going to use this house today as kind of a learning example for how to place textures on something that's a little bit more complex than a box. Now, if we rewind a couple weeks and go back to the Lighthouse assignment, we had some pretty complex geometry in that project that we were applying tiling textures to. What was some of the larger challenges associated with that assignment?
Putting a texture on a round cylinder.
You got it. Is those projection types, right? Those texture locators. That was a big time issue for us, right? Wiring that all in and getting the texture locator specifically aligned, the object that we are aligning it to, can be a monumental pain in the rear, and it's definitely not the best way of wrapping some textures around some polygons. Let me illustrate this problem that we have here, and we'll see this here very directly on the roof of our house. I think I want to put a tiling texture on the roof of our house. I spent some time while you guys are working on lab just finding some images on textures.com. This is going to be the tiling texture that I want to put on my roof. This cool little slate pattern, okay? Let's jump back over into Maya real fast and start wiring this network together. I'm going to open up the old Hypershade and start putting some stuff in. You can use, this is something that goes beyond any of the standard materials. If you're using Arnold, the AI standard surface shader is great. Blends and Lamberts, all really great things. Let's just do AI surface. Oops. All right, and I'm going to call this new, I'm going to call this new shader, this new material, roof. All right. Under the color channel, let's wire this in. Let's load in the file that's sitting on our desktop at the moment. I'm over here in the attribute editor now. I've saved these files right to my desktop. Voila. All right, so there we go. Now we can start applying those materials to the selected components inside the scene itself. Let's just jump in. I accidentally docked my Hypershade. All right, so here's all the materials, or all the polygons, that I want to have. Oops, forgot these guys over here. That I want to have that slate texture be applied to. Shoot, we'll even put it on this one too. Why not? Since we're here. There we go. Right-click, assign existing material. Let's turn on the visibility of our textures. Oops. Come on now. Lights. I always forget the shader display. Why are my textures not showing up? I do not have a light. Thank you. Let's do this. Let's just add a simple directional light into the scene. This texture should have shown up if there's a light, but let's just roll with it. Go. There it is. Now they're showing up in the render, but why are they not showing up inside the viewport? Yeah, hitting 6 should turn on my textures. That's okay. We'll roll with it.
Is it an Arnold surface?
Could be. Let's change the surface material. I want an answer to that question. Let's just put a Lambert in there. All right, same thing. This time I'm going to assign it to the Lambert instead of the Arnold. I wonder if it has something to do with viewport 2.0 and the Arnold rendering engine. All right, that's good enough for me. Nope, not an Arnold thing, but at least now we have an answer to the question. Okay. All right, let's do this, because now I can work a little bit more directly. So this is the problem that I have, right? If you look at what's going on inside of my scene, man, we have some big-time issues in here that we need to resolve. And I'm going to make this a little bit easier for everyone to see by going in and just putting a default sky dome in there. Yeah, now we can see it. Okay. Yeah, we got some problems. Visually looking at the roof here, what are the problems? Yeah, so it's the wrong size on certain parts of the roof. If you look carefully just in this angle here, on the lower roof line, the texture is one size. On the upper roof line, the texture is a different size. And on one roof, the tiles are facing down. On the other roof, the tiles are facing up. Boo. And if I was to zip around to the other side of my mesh, yep, that problem persists. In here. I may have, and that's okay if I did. Yeah, right there. Oops. Yeah, that's just a sloppy selection on my part. That's okay. So we have some big problems that we look at the way the texture is showing up over here. That's not so hot, right? Now in the past, what we've done is that we've added in that projection node. We've started to define some global shading parameters for our texture that's going to place the image across this entire thing. Let's open up our hypershade and check that out. All right, so here's roof 2, which is currently assigned to the roof material. Let's just get rid of this one. Delete. There it is. All right. And let's just throw in that projection node, just like we did earlier. And then with that projection node selected, of course, we can do interactive placement. We also get this projection type, which allows us to very quickly redefine how this image is going to show up. Now, at least it's better with this projection node, right? At least we're able to control the tiling size of this image a little bit more directly, okay? But the illusion that we're getting here is still only working on certain areas, right? The current projection type for this object is set to planar, okay, along the y-axis, but along the other roofs that are facing 90 degrees, the angle of this primary one, we're getting all stretched out, right? So how could we fix this using the existing framework? Could add another instance of this material and rotate the projection node 90 degrees so that on the secondary material, all the roof tiles will be facing the right way down over here. That's doubling up the work. That's adding a tremendous amount of effort just to get all the roof tiles on the same material facing the right direction, right? Thumbs way down on this one. Thumbs way down. These projection nodes are really good for global shading, for something in the background, right? Something that you really don't notice all that much. Maybe like a ground plane or a sphere, something that kind of matches the projection type over here. If you look at these projection types, there's only a couple of them, right? There's planar, cylindrical, spherical, triplanar, which is actually pretty good, right, for organic stuff. But that's kind of it, right? How often do we see a planar shape, an absolute flat surface? Cubic shape, absolutely cube, or absolute cylinder, or absolute sphere? Very infrequently, 9.9 times out of 10, our models are going to be based off of those simple shapes, but at the end of our modeling sequence, they're going to be complex surfaces, right? Where all the planes of our materials are going to be facing these really weird directions, and they're not going to look anything like a box, a cylinder, or a sphere, right? So it's a good start, but it's definitely not the preferred way of working. The preferred way of working when it comes to textures is to create something called a UV map, okay? And a UV map allows us to create custom locations for all the surfaces inside of our scene. And those two-dimensional textures are then going to be projected onto those custom locations very accurately. Think of it like this. What we're trying to do here is create kind of like wrapping paper, right? The textures that we download from the web, they're two-dimensional, like a flat piece of wrapping paper. And then we need to wrap that wrapping paper around our birthday present in a very specific way, right? Our birthday present in this particular situation looks like a house. So we need to have the pattern of that wrapping paper precisely match the curvature and the angles of that house in order for the computer to physically shrink wrap that texture around the house, okay? We're basically doing the entire clothing manufacturing operation in reverse, right? We're starting with the finished garment. Like all pieces of clothing are just pieces of, all clothing is three-dimensional at the end, right? When it's sitting on a human being or hanging up on on the rack itself, it's three-dimensional. It takes up a volume. But if we really just start breaking it apart and ripping it across the seams, my shirt here very quickly turns into a two-dimensional piece of fabric. We're going to do with UV mappings the exact same thing. We're going to take our final finished model and we're going to rip it apart at its seams so that it lies flat on the table. Once it's flat, once it's two-dimensional, the images that we're putting on it are going to wrap back onto the 3D model correctly. So we're kind of going, we're kind of going at it in reverse. Okay.
Can I see the node structure that you have for that, for the projection node?
Certainly. I'll make it bigger.
Okay, that sits in.
Yeah, it sits in between the file node and the material itself. All right, so what we're going to do here to get what we're after is not use this projection node, okay? We're going to use, let me wire it back in. There it is. We're going to use UV maps, which is the default projection type for all of the materials inside of Maya. Now this requires us going through an extra step, but it's really not that bad, and it's really pretty easy, especially for incredibly angular shapes like a house. We're going to kind of dip our toe into UV mapping in this course, and then when you guys go on and take 3D modeling too, we're really going to jump into UV mapping in a big way. Okay? UV mapping is an art form. It's a required component of the texture pipeline. If I wanted to put, like for example, maybe I'm doing like a character, if I wanted to put like a scar on someone's face on the texture itself, if I wanted to paint some custom armor or a damage or a uniform of some kind, I'm going to need local texture information, local texture coordinates called UVs, in order to place that thing accurately. To put that logo exactly where I want it. To put that scar or the chainmail pattern exactly where I want that illusion to go, right? It's a required part of our pipeline, and it really fundamentally needs an extra additional step. And let me show you what that extra additional step is going to be. I'm going to get rid of this. And here's the model that we're going to be working on, which is pretty fun, right? FYI, here's kind of a neat little trick. We have what's called screen space ambient occlusion. When I turn it on and watch what happens, get little cool little shadows, which is kind of neat. That's a way to kind of visually start breaking apart all these planes and what have you. I love the screen space ambient occlusion. It's just a simple little thing that just adds a little flair to it, a little bit of fun, especially when you start having some really great high resolution stuff in here as well. You start putting in other parts and pieces. It really helps visually start breaking apart all of those planes and what have you, so that you can start seeing it. Okay. All right, let's get rid of all my wood beams. I'm still working on this thing, and yes, I modeled to this resolution where I'm physically create geometry for every wood plank on the darn thing, because that's how I roll. But wood planks, I know it seems like crazy, right? And well, maybe it is a little crazy, but I like crazy. That's where I live. Okay. How did I actually make all these wood planks? It's a little bit easier than one might imagine. What are they? There's duplicates. I made one long rectangular piece, duplicated it about, I don't know, 1,000 times, right? And then I started slicing it up. And I started to very quickly just use multi-cut. If I go in here, see, just adding some slices in there, then moving those slices around ever so slightly to kind of break up the planar shapes and give each board kind of a unique personality. It's kind of a lot of fun. Then I use some booleans on this piece here, for example. Oh, not on that piece. Oh, no, yeah, I did down here at the bottoms. I think there's some other ones that I actually cut the openings for the windows, and they're kind of weird shapes, but booleans were my lifesaver in those. I don't remember which one it was, but not difficult modeling, just a lot of it, as they say. Okay. All right, let's hide that piece. All right, and let's get back to work on this guy. All right, so I want to create some UVs for some very specific components on my mesh itself. And I'm going to start with the house, or I'm going to start with the roof of my house, and we'll see how changing that, or adding this new element, these new UVs into the texturing system, gives me, or what it gives me. Okay, so go into my polygon selection set, and I'm just going to work with this guy in here, and I'm going to, Shift A, I'm going to hide unselected objects just to kind of filter my scene on that. All right, so what we're going to create here, or what I'm going to ask the computer to create for me, is basically a pattern of this roof, a two-dimensional pattern called the UV. Okay, we do all of our UV editing in what's called the UV editor. You can find it way up here at the top, right there. Okay, UV editor. Let's go ahead and open it up. Here are a whole bunch of UVs that are already created for this particular version. I'm just going to select them. Hit the backspace key. Bye-bye. And now we're going to start from scratch. Okay. This little icon right here. If you see your image, this one will turn it on and off for whatever material is selected. It doesn't delete it. It just turns off the visibility of it. Sometimes with the visibility of that texture off, it's a little bit easier to see what the computer's doing and understanding how what we are doing in the OpenGL viewport is creating the UVs in the UV editor. So like I said, what we're going to do here is that we're going to create a two-dimensional version of my little roof. And there are a lot of tools and a lot of workflows that we can employ to get this two-dimensional version, but we're going to keep it pretty simple because there's a really great command in here that's automatically going to go in and look at each of the planes on our objects and break them out into two-dimensional surfaces for us. Okay, as one might imagine, it's called auto scene. Okay, at the top here, these menus do a really great job of kind of defining the workflow of all of our UV tools and our UV mapping sequence. So if we start in the create, okay, we want to create some UVs, a two-dimensional representation of our three-dimensional polygons. This is where we're going to begin. So I like just doing a little automatic. Watch what happens. Automatic. Oop, didn't have anything selected. Sorry. Got to have an object selected first, and then it'll work. Now, it did all of them. It didn't do just the selected ones. That's because I didn't have anything selected, because I'm a dork. Let's try that again. Yeah. So I had my roof selected, and then I ran automatic, and this is what it pumped out for me. Okay? If you look very carefully in here, check it out. This is one side of the roof. This is the other. What are these big arrows over there? Yeah, the two end caps. So it's trying to do its best to find the different planes of this shape and automatically break and generate the UVs from those planes. I hit the Q key here. In the editor itself, there's some selection states that I want you to be mindful of. This first one, or this last one over here, this allows us to select the UV shells. This is going to select the actual points of the UVs themselves. Let's go into the UV shells. It's a little bit easier to work with. And check it out. Now I can move that shell around. I can rotate it. But now I have a whole series of parts and pieces. Well, let's examine the big product of this, the outcome. Why we have chosen to do this. Okay? I want to open up good old Arnold. See, I've been working on, I've been working on this roof here. Now, these end caps I didn't assign to the roof 2 material, which is why they're showing up gray. But look at the texture now, okay? The slates are very big, the individual tiles, and it looks like the orientation of the texture is going screen left. Same with this one over here. Now watch what happens when I start messing around with my UVs. And I'm just going to use move, rotate, and scale. If I was to scale my UVs, look what happens. Okay? Now I'm in the driver's seat as to how this texture is going to show up on the mesh itself. Okay? Maybe I want, and let me just see which one I have selected here. Don't worry about the size of them. Okay? Maybe I want the pattern to go up. Well, if I rotate it 90 degrees, oops, going the wrong way. There it is. Ah, wonderful. Yes. Looks a little disproportionate. If you look specifically at the little tiles here, they look like they're arrows instead of perfect half circles. So if we scale it non-uniformly, we can continue to adjust. Yeah, there we go. How those UVs are going to look. Okay? Or how the texture is going to show up on the mesh. The UVs create local texture information that directly determines how this two-dimensional image is going to show up on our three-dimensional polygons. It allows us to work very quickly and customize to this model how this tiny texture is going to show up on our mesh. Okay? Oops, rotated that other one the wrong way. Wait. Hold on a sec, let's make sure. Aha, okay, interesting. Which one do I have selected here? So what is this one? If I scale this one up, and uh-oh. Huh. Isn't that weird? What are we seeing here? On that side of the roof, it's good. That side of the roof, the tiles are going the opposite direction. When I scale this UV, both sides of the roof are changing the size of their texture. Can you see it? It's an interesting illusion, is it not?
No, that's the entire roof.
It's the entire roof. It's the entire roof. What we're seeing on the other part is actually, I would imagine, is something else on the mesh. Maybe, well, I can figure it out. Yeah, it's the underside, which isn't currently assigned to this material, the roof 2 material. I didn't do the underside. So let's just do it real fast. Okay, there it is. So if I wanted to get, let's go back to the top of my roof for a second. If I wanted to be able to control both sides of the roof independently, right? Because I need the pattern of this texture, the roofing tile pattern on this texture, to be going down. What do I need to do? Right now on this one UV island, I'm selecting both of them, and I'm manipulating both of them. See? We need to separate them out. Absolutely. The automatic UV creation engine is just an algorithm. And it's just going to look at the mesh, and it's going to try to break these UVs into a whole series of islands that it thinks is appropriate. But it's our job to interpret that and see exactly what's going on, and then to edit those UVs to get what we're after, right? So we create, and then we almost always edit. Luckily for us, there's some really great edit tools, and the UV editor has a whole series of tools over here. FYI, the creation tool that we just used is also right here, 6 to 1, half a dozen to another. It is fundamentally the exact same command, just in a different spot. Right below it, we have the cut and sew tools, and this is what we're going to do. We're going to start cutting these UVs away from each other and making a new seam. And they have a really great tool called the cut tool. Hit the Q key to go back to my selection engine. Here it is. Here's the cut tool. Now how this works, if we just click on an edge, see how it popped it away from each other? I cut the seam and made them two independent islands. Let me do that again. It's looking for seams or looking for edges. Just boop, click on it, breaks apart. Hit the Q key. I'm going to go back to my UV island selection engine. And now, check it out. Now I can start, let's see, which one's this? Now I can rotate this 90 degrees, or excuse me, 180 degrees, and get the result that I'm after. There it is. Now the roofing tiles are going down on that side of the roof and down on that side of the roof. Okay? Try to get this happen on your little birdhouse. Almost every single one of us in here has some sort of slanted roof for the birdhouse. That's why I asked you to do this. Make some UVs real fast. Put Italian texture on there real fast and see if you can recreate this entire example. Okay? You got to get your hands dirty with it. And I'll walk around and answer questions and help you guys out and smash some bugs. Yes, sir.
Selecting the polygon. It's not letting me, I'm not really sure what I'm supposed to do.
Ah, you're not in the selection engine. If you look carefully over here in your toolbar, you're in something else.
Oh.
There you
That's
go.
weird. I didn't realize I hit that.
Yep.
Thanks.
It's okay. Where can we go to find all these tiny textures? Textures.com. It's a great place to land. Yes, sir.
So I played around with it a bit. Trying to figure out how to make this side match this one, like with ease, like scale-wise. Like, is there a way to like copy this scale and put it in?
Kinda, yeah. And what you want is, let's see, so I'm going to transform. Yeah, so it's under this Textile Density section of the transform tools. So if you were to get the value, okay, see how it updated it, then you could select it and hit set, and it should pop them into the same scale. Okay, sometimes just seeing someone go through this process is really helpful. There's a lot of repetition, a lot of muscle memory that we need to build. So I know you guys are still working, but I'm just going to kind of talk through this entire process of getting the roofs kind of dialed so that we have a frame of reference here. I'm going to do the exact same thing that I did before, but on this lower roof. So I got it selected, okay? I'm going to open up my UV editor, right? And now I'm going to run automatic. And there they are. Wonderful. There's all my UVs, okay? Now that I got them kind of dialed and set, okay, I'm going to start customizing them. And this is where we're looking inside the viewport. Yeah, this one over here, I need to rotate it. Hold down the J key. There we go. Now, at the very least, the roof tiles are both pointing the right direction, but I need to make them kind of match the size of their friends. And I'm just doing this visually. That's pretty close. Yep, maybe a little bit bigger. You could get very exact, by the way. And I encourage you to do that. There's no reason not to. All right, that's looking pretty good. Oops, looks like I did the underside as well. You can delete UVs if you'd like. You don't have to keep them. Sometimes I delete them just so I know how they're all working. That's working pretty good. Let's do the exact same thing for the back side. Create, automatic. Now we're in edit world, okay? Then we have this entire grid here as a canvas. Sometimes it's easier just to move it all out of the way into a different component or a different quadrant of the canvas, which will allow you to very quickly start to select some stuff, okay? Now for this one, I got some problems on this one. Oops. Yep, looks like I'm going to have to really, now they're both going down. Yep. I'm going to scale them first, or excuse me, I'm going to orient them first, and then I'm going to go through and scale them all together as a unit. That way, at the very least, they're all facing the right, or they all have the exact same scale parameters. That's good. Quick work nonetheless. Rinse and repeat. I just continue working around the roof lines, putting all those things together. Okay. Earlier, Sebastian asked, is there a way for us to very quickly and very accurately ensure that the texture looks the same, have all of these islands be proportional to each other? Yeah, absolutely. Absolutely. If you'd like to do that, and let's just do a real extreme example here. There we go. Now we can see on these little jet out pieces here that the texture is of different resolution and size. It's much bigger in comparison to the shape behind it, okay? So one of the things that we could do is I can find that island, okay? So I've selected it here inside of my UV editor, and then over inside of my tools section, not tools, excuse me, the transform section of my toolbar right here, we have a really great tool down at the bottom called Textile Density. I'm going to get the textile density of the selected island. Now I'm going to go and find the other two that I want to change. I want to set it, okay? And now they're the same size. We're kind of like sampling the scale of one island and applying that value to another one, which is pretty exciting. That's a fast way to get everything on the exact same page. Shoot, I'll just do it for these two as well. Set it, made it just a little bit smaller. I was darn near close. And now I have some pretty great consistency with inside the mesh. Ta-da, looking good, looking real good. Starting to come together, right? This is how we create super accurate textures that perfectly match the curvature and slope of all the different planes of our objects themselves. And with planar shapes like a house, it's really easy and very fast to kind of get through this process, okay? Let's build upon this idea a little bit and really start to understand the power of working with UVs, because I think for me, I want to have another material in here that's kind of like a plaster. I'm going to go for this kind of like old English style house, okay? And if you look at the way all of this is constructed, the top half, you got the foundation level at the bottom, and then the top half is usually like a plaster, and then all of these things are going to be wood beams in there as well. So I have some work in here that I need to do. If you look at the textures that I've downloaded from textures.com, here's the plaster texture that I'm going to use for the top half. Here's going to be the stone foundation, and this is going to be the wood planks themselves. And this is just a real quick start. Let's jump back over into Maya and start off by physically creating all the materials that we want to use. Okay, I'm just going to use Lambert's just because it's fast and easy. This will be plaster. I like to create. This one's going to be stone, and then one more. This one's going to be the wood. All right. So let's start with the plaster. Let's graph that one up for us. Okay. And now we need to go through that exact same process that we went through before. We're going to add the color texture by inserting a file node into our graph. With that file node selected, the image name channel over here will allow us to load in the image that we're looking for. This is the, which one is this? This is plaster. There it is. Okay, that one's in. Let's do stone, same thing, color, file node. Let's go find that stone texture. There it is. And then here's the wood. We'll graph that one too. And voila. Okay, we're done here. Now it's just a process of assigning polygons to certain materials. I like to create my materials first. It's a little bit easier to select and assign once the materials are created. Okay, so this entire top half is all one contiguous piece. So right-click, assign existing, plaster. And now let's create some UVs. Display, hide unselected, just a great way to very quickly get things going here. And now let's run auto seams or auto create in the UV editor and see what we get. UV editor. I want to select the shapes that I want to automatically create the UVs for. Create automatic. Okay, there they all are. They're sitting down there at the origin of my UV grid. Here they all live, which is kind of nice. All right. So awesome, but maybe not awesome at the exact same time. We have some work in here that we need to do. And this, luckily for us, we're just going to start rotating these. Cool. Oh, actually, I think it's rotated backwards. Yeah. It's upside down. Okay, so this is the top over here. Rotation tool, holding down the J key. Kind of move that out of the way. Let's just do these. Okay. All right, so now almost done. I'm just going to do the outsides. The insides I know I still need to fix. But now comes the fun part. This is where we get to be creative. And this kind of really speaks to the power of the UV editing workflows. Now I get to customize how this texture is going to show up on the walls, right? I can globally, let me just grab all the parts and pieces that I'm working with now and just kind of visually group them, the four walls. Just want to make sure. Yep. Now, okay, so now with those things selected, what I'm going to do is that I'm just going to scale them up a little bit. Yeah, there we go. Because now I can see more of the image inside the polygons, but my illusion breaks down pretty quickly, right? What's the big problem that I have with my textures and their corresponding UVs? Yeah, this is a seamless texture, but it's only tiling along one axis. It's only tiling horizontally. It doesn't tile vertically very well, right? This is the bottom of the image, and then this is the top of its next repeat, of its next stamped pattern, right? So I got something here I got to fix, but luckily the UV editing pipeline allows us to do that pretty quickly, right? You just move the UVs around. Voila, problem solved, right? Instead of moving the texture, we move the UVs behind it, which makes it go a whole lot faster. Let's find this one. And maybe I want to have it be real similar. What I like about this plaster is we get a good freebie down there at the bottom, right? We get some really great texture information that's going to give my building a tremendous amount of life. We have all this lichen and dirt kind of accumulation down there at the bottom where it naturally would be. So I want to make sure that's right down there at the bottom of my walls. It's kind of a nice little bonus. If you look at the way that I'm situating all of these inside of my UV space, I'm trying to get them generally, sorry, zoomed in on the wrong one, generally kind of oriented at the same place inside of my UV space. That's why I'm getting a kind of a consistent reproduction. That's the exact same image, but each wall looks a little bit different, which is kind of nice, right? Because of its placement inside the UV space over here in our editor. And this wall I don't care so much about because it's actually behind a gigantic, the rest of the building, but I'll follow the pattern that I've established. There it is. And that looks pretty decent. Pretty decent. I like that. We're starting to get somewhere, right? Let's do the exact same thing for the bottom part, right? I'm going to unhide the rest of my mesh. Oops, didn't select anything, my bad. Okay, we're getting there, right? Let's do the exact same thing on the bottom. With that selected, we'll auto create. There they are, down way down there. Oops, I didn't hit auto. I think I hit camera based. There's auto. And now, oh, you know what? I don't think I assigned a material. Yeesh. That's not very good. Okay. Here's this one. Stone pattern we can kind of get away with, right? It's going to be a little bit, well, actually, if you look very carefully, sorry, I want to make sure that I'm honoring the shadows that are in the actual texture themselves. Make sure those are down at the bottom. The illusion would break pretty quickly, right? If it was like that, now it kind of makes you feel uncomfortable and weird. That's because the shadows are going the wrong direction. And let's see. Last, I'm not going to go the insides on this particular moment. There we go. And now with all of them oriented correctly, I'm going to scale them together. That way, they all kind of match. Cool, huh? Looks pretty great. I like what I'm doing here. This is turning out better than I thought it was going to turn out. Let's unhide the rest. Might help if I select something first. Yeah, and now we're starting to craft a pretty compelling illusion here that's getting closer and closer and closer to what I'm looking for. Okay? Rinse and repeat. Rinse and repeat. You can do large chunks at the exact same time, too. You know, like all the wood beams. The wood beams would probably take the longest, right, because there's a lot of them. For the wood beams, you know, you certainly could get a little creative here. For the wood beams, let's just try it. If we did an automatic, this is what we get. Yeah, actually, oops. Yep, the wood beams are pretty straightforward, just 4 independent sides. Much like we have the cut tool, which will separate out the polygons from their corresponding UVs, we also have the sew tool. Because sometimes having 4 independent UV islands can be a pain, right? Having them all connected makes them easy to work with. It's just one thing to select versus 4. So check it out. In addition to the cut tool, we also have the sew tool, which works almost identically. I had to be in edges, by the way, in order for this to work. Yeah. There it goes. Oops. Had it a second ago. Aha. So what's going on in this moment is that these are out of order. So when I select the edge, see how it's selecting both of these edges? Okay. Why am I selecting pairs of edges? Huh? It's not duplicates. It's the exact same edge shared by two different surfaces, right? Two different polygons that are connected to each other are going to share a common edge. So the computer's automatically selecting that edge for me. So if I wanted to sew this UV to that one, look how the edges are working. I select that one, but it also selects this one over here. So if I wanted to sew them together, this one's got to be flipped, rotated 180 degrees. Now, when I try to sew them together, there it is. I want to get them a little bit closer to each other to maintain. I'm still in the sew tool, by the way. And, you can also sew this way. Stitch together is kind of fun. Yeah, stitch together is going to keep their relative size. Let's do stitch together. See how it moved it? Yep. So we can add, combine them and also separate them out by cutting them together and sewing them together. Just like a seams person would do, a seamstress would do, cutting and sewing these different pattern pieces on a clothing garment together. And when they're all combined into one UV island, it just makes it a little bit easier to manage. And I can see by the orientation of the grain, what do I need to do to my UV? My little wood plank here, the illusion is completely broken, right? What should I do to my UVs to get the texture to show up on my polygons correctly? Yeah, it's rotated 90 degrees. That way the wood grain is going the right direction. There it is. Now, at the very least, it's beginning to look like it's supposed to. Voila. Pretty cool, huh? Pretty cool. This is the power of UV mapping, okay? It allows us to create custom local texture information that our images will then use when being wrapped around the model itself. That projection node in the hypershade, those are global texture coordinates, right? And 9.9 times out of 10, it's just not going to do the job. It's a good start, right? But UVs are the path to success. All roads lead to Rome, as they used to say, right? And us in the texturing world, all roads lead to UV maps. Gotta have it if you want to be able to control your meshes the way that you want to in order to get the illusions that we're after, right? I'm a big fan of a piece of software called Modo. I'm a longtime Modo user. I really enjoy working in Modo, right? When Modo first came out, they had a whole bunch of T-shirts, right, that they used to advertise their software. And I was a big user, and still am to the day. And they had two different T-shirts because Modo was originally billed as a very fast 3D modeling app, and it still is probably the fastest 3D modeling app. The tools are very organic and conducive, right, to the artistic workflow. It also gives you a lot of control. Like, you can really micromanage. And I'm a little OCD, so I love being able to micromanage my meshes. I have a Modo T-shirt at home. It says "Control Freak," right? You got to be kind of like a control freak when it comes to your 3D models, right? To be able to kind of manage the chaos a little bit, UV maps are the solution. Okay. So here's what I'd like you to do, and let's just take a couple more minutes. Get used to making some UVs for your birdhouse. Many of you guys have already done the roof. Great. Finish the birdhouse real fast. Make UVs for every single polygon on your birdhouse. Assign it to a material and start getting used to working inside of this UV mapping workflow. And I'll walk around and give you guys a hand. UV maps do a wonderful, wonderful job of allowing us to create local texture information for the surfaces of our model. It's a required step, and it just allows us to produce a level of detail with the textures that are just fundamentally not available when using that projection node. So it's a good process to go through. Get used to doing this. If there's one skill that I would recommend that you practice and you push yourself to master, it's UV mapping, because it's going to be a skill that's going to follow you the rest of your career as a 3D modeler. Okay. Now, we're going to be doing some renders this week of our house, and I wanted to show you some really neat technology in the Arnold rendering engine that will provide us a level of realism that I think you're really going to enjoy. Now, in this particular scene, I've just added our good old sky dome in the background, and things are looking pretty fantastic. I'm not going to put an image in the background. I could go in and monkey around with the color, but I want to start crafting an illusion that's a little bit more atmospheric, and certainly something that I can control. I always, as an artist, want the ability to art direct. I want to be able to put the shadows where I want my shadows. I want to have the color temperatures of the light match what I, as the artist or as my creative director, wants. Okay? We always want to be able to control, the magic trick a little bit. Reflection maps, those are just images. They're a good place to begin, but you can't change the photograph, right? Once that little exposure is created, you can't go back, right? You can't change where the trees are. You can't change the pattern of the clouds in the sky or where the sun in the reflection map is going to be placed, right? So there are some other options inside of our rendering engine that allow us to very, very quickly start crafting a more controllable illusion. Thus enter, and I'm going to get rid of my AI sky dome, bye-bye. Thus enter this guy, physical sky. The physical sky is seemingly a kissing cousin of the good old sky dome, but there's some extra attributes that we can find in our attribute editor that give it more power. Right? Let's go ahead and add it in. You can see down here at the bottom, it actually comes in as a sky dome. Let me start the good old preview engine, already looking a little bit cooler, right? Now instead of a solid color in the background, what are we seeing? A horizon line, right? We're starting to craft a more realistic illusion of the sky itself. If we jump into our attribute editor and look at all the input and output nodes of this object, it gets even cooler. Okay, let's do it real fast. All right, so I'm in the attribute editor now. Just make it a little bit smaller so we can see it. All right. And specifically, if I click on the sky dome, okay, of course we're going to get a lot of the sky dome properties that we're used to working with already down at the bottom here. But if we continue to examine all the output nodes of the sky dome object in our scene, check it out. We have the default light set. And then way over here we have AI Physical Sky 1. This is what I want to look at, right? Because these have the specific parameters that allow us to change the background. The background is a dynamic element with these physical skies. By changing the elevation and the azimuth sliders, I get to basically change the time of day of my environment. Check it out. It's pretty neat. So right now my elevation's at 45 degrees. If I was to change that value, watch what happens to the illusion on my building here. As I lower it, what's happening? The shadows, the sun is getting lower to the horizon line. Not only are the shadows continuing to rotate and follow the angle of the sun in the sky, but the color temperature of the light that's illuminating our scene is also changing to simulate how the color temperature of the sun would look at the beginning of the day. If you look very clearly on the preview render here, you can see now that we're getting very, very orangey. And then as I continue to push this value down, here we are at like magic hour or at like dusk when the sun is below the horizon line, but it's still kind of light out, right? It's pretty neat. It's pretty neat, okay? So the elevation is going to determine the angle of the sun in the sky itself. If you look very carefully here, look at the angle of the shadows as this elevation slider has changed. Here we are kind of the middle of the day. The sun's right above us. Well, now we're kind of more at the middle of the day. Sun's pointing directly down at us, right? So the elevation would be how high the sun is in the sky, right? When it's at its zenith, it's immediately over us. 100%, right on top of us. If you look at the shadows, especially on my little chimney here, you can see pretty quickly just the tops are being illuminated. The bottoms are completely in shadow because the sun is completely, it's right above. It's like 12 o'clock noon. So the elevation, that's going to change the angle of the sun and the sky itself. Now, I mentioned earlier that maybe perhaps I want to continue to art direct this a little bit more. What if I wanted to have the sun behind my house, right? Because right now it's kind of in front of my house. That's the role of the azimuth slider. As I start to change this azimuth, now I'm rotating the entire globe, if you will, okay? The sun, well, I'm not rotating the globe. I'm actually rotating the sun around us like this, okay? If we keep cruising here, watch the shadows as they go across the roof. Eventually we'll get to a spot somewhere over here. Now it's kind of coming behind. I'm going to lower the angle. And let's see if I can get the sun to show up right behind the house. It's pretty low. Oh, there it comes. You actually see the bloom of the sun. There it is. Oh, I missed it. Voila! Hello, Mr. Sun. Oh, Mr. Sun. Sun, Mr. Anyone? I have children at home, so these crazy kid songs are part of my daily life. Anyways, okay. So we actually get a solar disk, as it's called. We get a physical representation of the sun in the background of our scene, which is really cool because now we can start to kind of create the illusion, right, that we're after. If we keep cruising down here a little bit, there's a parameter called sun size. As one might imagine, what is this going to do? It's going to make the sun bigger or smaller, depending on what we're trying to create. Mega sun, right? The sun is not that big inside our sky. Shoot, let's make it really big. Let's drive it to 15. Okay? Now,
as it gets lower, it actually starts to darken at the bottom.
yeah, isn't that cool? That's exactly what I was going to talk about. This is kind of it speaks to the power of this physical sky system here. See how the sun is changing its illusion here at the bottom, as if maybe it's going through some atmosphere and it's changing its color temperature as most of its sun rays are going below the horizon line. That's pretty neat.
That's what turbidity does.
Yeah, and turbidity is going to go in and start creating the kind of that fall off. The first slider up there, I didn't gloss over it. I was just coming back to it. Turbidity. At the default value of 3, this is what we get. If we turn it all the way down, now there's almost kind of none of that natural haze, okay? Now we're just getting that solar disk and some general illumination. It's almost as if we're kind of like blurring the boundaries of the sun's influence. Look at that. That's kind of cool, right? Now it's more like a moon instead of, I don't know, the sun. The moon's rising behind us. Yeah, I don't know. It's just a whole lot of fun playing around with this really cool, simple illusion. So these sun properties are pretty neat. I definitely recommend that you play around with them, okay? They're going to create some really cool effects. Now, when it comes to lighting inside of all 3D apps, we need to be mindful that we're probably more than likely going to need more than one light inside of our scene to produce the illusion that we're after. Let's pretend that this is 6 o'clock in the morning, the sun's on its way up, and this is the angle that I want to have in the final render. I'm going to need some additional lights in here to continue crafting the render that I'm trying to make. I try to put myself in the mindset of an actual photographer. Okay? If I'm a photographer out there in the real world and I'm backlighting my entire subject, I'm going to need to blast the front part of my scene with a lot of light. Okay? I'm going to need to fill in the shadows here and maybe have some lights underneath or on the interior of my house to start filling in and punching out certain parts of my scene to start creating a really pretty picture. Okay? So when it comes to working with lights, we're going to need more of them. Okay?
Can you put in 2 physical skies?
I don't think so.
I was thinking
Yeah.
just from this, it made me think of tattooing.
Right, double moons, that'd be cool. Maybe, give it a try. I've never honestly tried it. I doubt it though, but I've been wrong before. All right, so let's go ahead and start adding in some other lights in here. And I recognize pretty directly that the projector is kind of smashing the colors. On my side, I can see almost the entirety of the building, but I want to start to fill it in a little bit to start creating some really neat illusions. Okay. Now, one of the cool things about working in the rendering system of the computer is that we get to completely break reality. Okay. I'm going to go in and let's do this. I'm in the rendering shelf. These are all the basic light types that we get to use. Okay. Generally speaking, ignore the ambient light. I wouldn't recommend using it all that much. It's a very difficult light to control. But these over here, the direct illuminators, are really quite good. We're going to start here with this one. This is the point light. The point light is like a flashlight. Excuse me, it's like a light bulb inside of our scene. It's just a single spot, and light is going to be emitted from every direction from that location. Let's go ahead and add it in. It's going to be placed at the origin of the scene. And let me just put it in a position here. And I think what I'm going to do is that I'm going to pretend that maybe I'm awake in this front room. And I'm going to position that little point light inside the house. Something like this. Okay? Yeah, that's looking cool. We can see that we have a little light coming out of our window. With that object selected, let's just increase the intensity quite a bit. Let's give it a good color. Nothing ever is pure white inside of our world. We work on shades of yellows and oranges. Let's try to get maybe something a little bit more incandescent. Yeah, there we go. We're getting there. We're getting there. I think I need some general illumination here in the front. The directional light is a great light type to use. The directional light, in every sense, is kind of like the sun. It's an infinite wall of light coming from a specific direction inside of our scene. When you go outside, luckily the sun is out right now, right? If you're going to go like over to the football field or just like some big open space that doesn't have any trees, you never can escape the sun, right? You're always in the sun. It's an infinite light source, okay? It's the radius of the sun far, how many, I'm trying to remember off the top of my head the diameter of the sun. I want to say you can put like 32 million Earths inside the sun or something like that. It's big. The sun is big, right? You never can escape the surface, the intensity of the sun. So the directional light, in every sense, is like the sun, okay? I'm going to put a directional light in. 1.3 million Earths? Or in diameter? Yeah. Okay. Say again? In terms of volume? Okay. So the directional light is doing a pretty okay job of going in and generally illuminating our scene here a little bit, but we're battling these shadows, right? Because now we're completely breaking the illusion of that wonderful solar disk in the background. I want to make this look like it's being illuminated from the back and we're just kind of filling in the shadows on the front side, right? Well, the great thing about working with computer lights is that if we have them selected, we can go in and we can turn off things like shadows, okay? So I'm over here in my attribute editor, okay? And, oh, you know what? Yeah. Let's turn off our shadows, our ray trace shadows. And we can also say illuminates by defaults. Let's see. You know what? I'm thinking of a different light type, but you can't turn off the shadows. Why are depth map shadows are not on? This is a product of the Arnold rendering engine. So where is it? Extra attributes. Here we go. It's in the Arnold section. I'm so used to doing this with Mental Ray. So I'm in the Arnold section, and now I'm going to turn off cast shadows, and all those shadows went away. Yep. Great. We're getting some interior shadows here, but that's not coming from the directional light, or I don't believe it's coming from the directional light. Let's test it. Yeah, not coming from the directional light. Now we're just providing nice soft illumination in the front, and we're starting to craft the type of illumination model that I'm looking for here. Maybe something like that, kind of from the side. I want to put another light in over here on the other side. One thing, let's change the temperature. This is just driving me crazy. There we go. That's a good place to begin. Another thing that you can do is that you can say, hey, don't emit specular, so don't make things extra shiny. You can also do that down. I got to do this in the Arnold section. I got to get used to doing that. Yeah. So I can say, hey, don't do any sort of specularity on this guy and only affect the diffuse values. So we're just kind of softly adding in some illumination inside the scene without adding shadows. That's the idea, right? Because the moment we add shadows, we're creating the illusion of multiple light sources inside the scene. I want it to look as though the sun in the background is truly responsible, even though it's not, right? I got a light on the inside. I got a big directional light on the other side. Let's add in another light. Let's add in a big old spotlight. Spotlights are like flashlights. If the point light is like a light bulb, the spotlight is like a flashlight. It's like a theater light. It has an orientation and a direction that it's going to face with inside the scene itself. So it's highly directional, and we can control it very directly. You can see it's starting to fill in some of the shadows. With that light selected, let's really drive its intensity up some. I want to increase the cone angle. Yep, you can just barely see its impact there. Can you guys see that? We're starting to see the boundary there. If I back this light off a little bit, yeah, that's cool. Make it real bright. I want to make this light kind of blue. By mixing and matching colors, you're starting to craft a really pretty illusion. So we're getting there. Multiple lights start to sculpt and shape our object. I may even want to put in a true third light inside the scene. I'm going to add in another spotlight here. And the role of this spotlight is going to be in the back. I want to flip it around. And I'm going to have this guy just blasting the top here with a tremendous amount of light. Let's really drive its intensity up. Let's put it at 50. Yeah, here we go. Now you can actually see it in the render down here. And let's put this up to like 200. Super bright. The penumbra is the fall off. It'll blur the edges quite significantly. Let's make it a nice bright yellow. Yeah, and it's just starting to get this top here a little brighter. Let's really drive it. 500. I think I have the angle of it slightly wrong. There we go. Let's try that. Yeah, that's looking better. Okay, so multiple lights inside the scene allows us to craft a pretty complex or a pretty creative result. It's not just one light. It's very rarely just one light. Often it's about 8 or 9 lights, all having a very specific role on the illumination of our object. So experiment around with this for your homework this week. Place a couple light sources. Try to sculpt and motivate as many of the different lighting effects that you're trying to craft. Mine's kind of hard to read at the moment because it's just kind of white, so and the textures on there are going to be influencing my understanding of all these shapes as well. But we want to play around with light. Use this physical sky. It's a great way to start kind of creating the illusion of a sky and in a controllable way, right? Reflection maps are a good start. They really are. I use reflection maps all the time, but sometimes I just want to be able to go in and just increase the intensity of this a little bit. Make it just generally brighter, okay? Well, like I said, just change the location of that sun by messing around with the azimuth. So look at that. That's already, I think that's actually a far superior render than what I had before. And thanks to those other 3 lights in my scene, it's filling in the shadows, and I'm not relying exclusively on the illumination of the physical sky to get the final result of my picture. Pretty cool, huh? Pretty neat. This is where we get to be this is where we get to be photographers and take pretty pictures of the houses that we've now constructed. So our mission this week, as we go through the conclusion of this architectural visualization module, is to, of course, make a nice pretty picture of our house. textures on everything. Continue to apply these UV maps so that you can control the placement of your tiling textures across the surfaces of your object. Okay? Also, don't forget about that background. It does have an important role. Put a reflection map in there. Use that physical sky that I just showed you. Those are really great techniques. And then add in a couple other lights just to fill in the shadow areas. We don't want to go from extreme brightness to almost black inside of one picture. If there's any part of your frame that's completely black, maybe you want to start imagining a different solution. Okay? Add another light in there. I think this one over here with the lovely Prius model in the front is a great example. They put a porch light on there, which I think is kind of fun, right? So go ahead and add those in, and you're going to find yourself with a really great series of renders. Okay? Questions on what we're doing this week? Everyone's feeling it? Yep? Yeah? Well, good luck. Oh, there is a question.
Well, it's more of a question towards, like, if the house, or if the render from, or if the geometry from this one looks different from the geometry from the last one, is that going to be a big issue?
It's not going to be a huge issue. Yeah, not going to be a huge issue. Should be the same house, but if you've improved upon it, that's a good thing. Yeah.
Yeah, I just realized I screwed up by making the back door a giant window, so.
I like it. It's a good sign that you're learning if you're looking at what you did the previous week and going, oh, I can do better at that, right? Or now I understand the shape that I'm trying to craft, and maybe I rebuild it real quick to get the illusion that I'm after. Yeah, that's a good thing. I'm revisiting right now. I'm revisiting an older project of mine that I made literally probably 10 years ago, and I never really intended this project file to go anywhere or do anything, and I'm kind of revisiting it to make it ready for a real-time rendering engine for some future classes. And man, every time I open up the project file, I go, oh man, what was I thinking? So face palms, like, what was I thinking 10 years ago when I made this model? I've ended up like rebuilding half of it just to make it work with my current skill set. So it's good. I hope that you're making changes to your model. That means you're learning something, and that's what we're here to do. Questions, comments? Everyone feeling it? Everyone understanding? All right, good luck. May the force be with you.